Hello everyone. Today we'll be solving this problem in LeetCode. So what the question is, we are given a graph adjacency list from 0 to n minus 1 node. And here it is saying that a node is terminal node if there are no outgoing edges, and it is safe if every possible path starting from that node leads to terminal node. So what the question is saying, for example, if you see this graph, 6 and 5. These two nodes are idle. You can say these two nodes are not going anywhere. So these two can be considered as terminal nodes. So we have to tell every node which can reach these terminal nodes. So those nodes will be considered safe. But the catch is, though those nodes should not enter any cycle. They have to reach these nodes directly or indirectly without going to any cycle. So we can see the answer array contains 2, 4, 5, and 6. We can see 2 is going to 5 directly, whereas 4 is going to 5 directly, and 5 and 6 both are terminal nodes. So if we see here 0, 0 is going through 1 to 2 and then 5. So why it's not considered as safe node? Because 0 is part of cycle. If we see this node from 0 to 1 and then 3 and then 0. So this is a cycle. That's why we are not considering 0, 1 and 3. So what most of the people have done is they've given the BFS solution to this problem, but I will be giving DFS solution today. So we'll simply make a let's just start by having the total number of nodes which are there in the graph. So that will be graph.size. And I'll simply make a vector. Let me explain you. Vector state of size n. And I'll take every node as 0. So what this state is, this state will hold the values just like a visited array we make using DFS. So it's the state. Instead of 0 and 1, we'll be using another. The 0 will depict that it's not visited, while 1 will say that it's being visited or it's visited, and 2 will tell us if it's safe or not. So we'll go through every node for int I equal to 0. So for every node, I'll check that I have to do DFS in every node. So I'll do DFS for I. I'll give it the adjacency list, which here is named graph and the state. So if it returns true, the DFS returns true, then I'll put that number in my answer. And then simply I'll return the answer. So let me just make the answer vector. Now I'll be defining the DFS function. I'll simply give it a node, the adjacency list, and the state vector. So first I'll check if the node we are checking, it has visited the array or not. If it's already visited, it's 1, we'll be returning false. Why? Because we know that if it's 0, the node is not visited. If it's 1, the I have not told you here. If it's 1, either we are visiting, it's depicting either we are visiting or it's unsafe. So if the state of that node is 1, will return false, which means it is unsafe. Or we'll check if the node is equal to 2, then it's safe, so we'll return true. And then what we'll do is we'll check it. Uh, First of all, I'll just mark the state of node as 1. Here, this one, as I told you, here, this one means that we are currently visiting the node. So I'll make a for loop for every integer in adjacency list of node. So we'll check all those nodes that are connected to this particular node, and we'll check if DFS of that node IT. So if the DFS is giving false, we'll simply return false, and it will go through all those connected nodes, and if it doesn't find any false, we'll simply move on to the next line and say that the node is safe, hence it's 2, and return true. So we'll just check it. Yes. So we can see our answer here is accepted. So let me explain it clearly. As 4 is connected to 5 here because it's not connected to anything. So every node that is reaching 5 is safe. So here 4 and 5 will be safe. So if we go through my code, so if we make a state array here, initially every node will be 0 here. So this is going to be the state array for 0, for 1, for 2, for 3, 4, and 5. So we'll start with 0. 0 will call DFS for 1 because it's connected to 1. Then 1, um, the state of 0 will become 1. Then DFS of 1 will be called, so this will become 1. Then again, we'll be calling for 2. Here, it will be 1. Then DFS for 3 will be called, so DFS of 3 will be also 1. So when we'll call DFS for 3, it will call DFS for 1. And we know that state of 1 is 1. Here you can see. So it means that the node is entering a cycle, or you can say that it's unsafe. So this here will return false. So each and every node will return false to 0. So at last, we know that this is going to be false. Then for the next node, which will be 4, it will call DFS. Uh, First we'll call DFS for 4, which will make it 1. Then it will call the DFS for 5. Now, if we see here, first let me make 5. So 5, if we check the code here, if we check the code, 5 will be returning nothing. The state will be changed, state of 5 will be 1. Then we'll go to adjacency, every node that 5 is connected to, but 5 is not connected to anything. So it will simply change its state to 0, then return true. So if we check here, 5 will simply change its state to 2 and return true. And since 5 had returned true, so the loop of 4 will end and it will simply change its state to 2 and return true. Since these two states have returned true, the answer will have these two numbers, which are 4 and 5. So these two will be safe. So that was the logic behind that DFS. Thank you.